So, Chapter 10. So, Chapter 10 deals with power series. So, first off, linear and quadratic approximation. So, linear would be in this form. Y minus f of a equals the derivative times x minus a, or the other way, write this is y is equal to f of a plus the derivative times x minus a. And then the quadratic approximation looks like this. That p of x is f of a plus the derivative times x minus a plus the second derivative of a times x minus a squared. So, for example, let's say we have this, that f of x equals e to the minus x, a is equal to 0, and we want to know e to the minus 0.2. So first off, linear. So f of 0 is e to the minus 0, which is 1. And then the derivative would be minus e to the minus x. So y would equal 1 plus minus e to the minus 0 times x minus 0, and x is going to be a minus 0.2, so 1 plus e minus e to the minus 0 times negative 0.2. Value of the 0 is 1, so this is going to be 1 minus 0.2, so this is going to give us 0.8. If we do this now in terms of a quadratic approximation, again, f of x equals e to the minus x. The derivative, first derivative, is minus e to the minus x, and then my second derivative is e to the minus x, and so now y is going to equal 1 plus minus e to the minus x, x minus a, and then plus e to the minus x over 2 x minus a squared. And again, a was 0, x is negative 0.2, so let's plug those in. Or e to the minus, we got here, minus x. Right. And 1 plus minus e to the minus 0, and this is going to be minus 0.2 plus e to the minus 0 over 2 minus 0.2 minus 0 squared. E to the 8. And so we plug this in. This is going to be 1 minus 0.2 plus 1/2 times 0.2 squared. And we end up at 0.82 in my quadratic approximation. Okay. So then you get to what they call Taylor polynomials. So a Taylor polynomial is in this form: f of a, the derivative times x minus a, the second derivative, evaluated a, over 2 factorial times x minus a squared, the third derivative at a over 3 factorial x minus a cubed, and so on and so on and so on. And so this would be e to the, somehow I lost my letters here. Right. A, right. Okay, all right. So that's my Taylor polynomial. All right. So let's look at one of these. So let's say we want to find the Taylor polynomial for e to the x. And so n is going to be 0, 1, 2, 3, so on and so on, right? So f of x is going to equal e to the x, and we're going to do centered at 0. Right? So p0 of x is going to equal f of 0, which is going to be 1. p1 of x is going to be f of 0 plus the derivative of 0 times x, which is going to be 1 plus x. p2 of x is going to be f of 0 plus the derivative plus the second derivative at 0 over 2 factorial x squared, which will be 1 plus x squared over 2. And then if we do the third term, and we can keep going on this, this is going to be f of 0, the derivative at 0, the second derivative at 0, the third derivative at 0, and so this is 1 plus x squared over 2 plus x cubed over 6. And then if we said, okay, let's say x is equal to 0.1, and well, p of 0 would mean this is 1. P of 1 is going to be 1 plus 0.1, which will be 1.1. P of 2 is 1 plus 0.1 plus 0.1 squared over 2, which is going to be 1.105, out to the next term. 1 plus 0.1 plus 0.1 squared over 2 plus 0.1 cubed over 6. And that takes us out to 1.05167. Oh, let's see, other things in regards to Taylor is we get the Taylor remainder theorem. And so Rn of x is f to the n plus 1 c over n plus 1 factorial times x minus a n plus 1. And this is for some point c between x and a. And then we can estimate the remainder. That is given by the f of x minus the power series at x, which is going to equal m x minus a to the n plus 1 over n plus 1 factorial. And so do this one now. So the Taylor polynomial, let's see, square root 18. So n equals 0, 1, 2, 3, square root of x. And this time we'll do centered at 16. So p sub n of x equals f of 16 plus the derivative at 16 times x minus 16 plus the second derivative evaluated at 16 over 2 factorial times x minus 16 squared plus the third derivative evaluated 16 over 3 factorial x minus 16 cubed. All right. So yeah, and by the way, the reason we picked 16 is because 16 is the number closest to 18 that does have a nice whole number square root. Right? So let's see. So first off, f of x is the square root of 16, which will be 4. F prime would be 1/2 x to the minus 1/2. And so the derivative evaluated at 16 is going to be 1 over 8. And then the second derivative is going to be minus 1/4 x to the minus 3/2. So the second derivative evaluated at 16 is minus 1 over 256. And then the third derivative is going to be 3/8 x to the minus 5/2. And so the third derivative is going to give us 3 over 8,192. So my series then, Pn of x is going to be 4 plus 1/8 x minus 16 minus 1 over 512 x minus 16 squared plus 1 over 16,584 x minus 16 cubed. And then we know that x is going to be equal to 18. And so this is going to give us 4 plus 1/8 times 2 minus 1 over 512 times 2 squared plus 1 over 16,584 times 2 cubed. And if we evaluate this, we get 4.242676. And then if we want to estimate the remainder, we have that Rn of x is going to be m 18 minus 16 to the 4th over 4 factorial, which will be 2/3 m. And so m greater than or equal to f to the 4th c for all c between 16 and 18. So f to the 4c is going to be minus 15 over 16 c to the minus 7/2, which will be a very small number. So power series. So k equals 0 to infinity, c to k times x minus a to the k. So given one like this, k equals 0 to infinity, x to the k over k factorial. And we want to find the interval and radius of convergence. So we're going to do this first by the ratio test. So r is going to equal the limit as k goes to infinity, x to the k plus 1, k plus 1 factorial over x to the k, k factorial. And so then this will become x to the k over x k plus 1 times k factorial over k plus 1 factorial, which would then become the absolute value of x times the limit as k goes to infinity, 1 over k plus 1 and this would go to 0. So r is going to equal 0, and so the series converges for all values of x. So let's say we have this one, f of x equals 1 over 1 minus x, which would be given by the power series x to the k. So 1 plus x squared plus x cubed plus so on and so on. And so my derivative then is going to be 1 plus 2x plus 3x squared plus so on and so on and so on. So k equals 0 to infinity, k plus 1 times x to the k. And so we got here in terms of, and we're going to do this in terms of 1 minus x to the minus 2. So the derivative is going to be 1 minus x to the minus 2 equals k equals 0 to infinity, k plus 1, x to the k. So then you get in terms of Taylor's series and Maclaurin's series, and there's not much difference between the two. So first off, Taylor series, and this is going to be centered at A, and so this is f of A plus the derivative times x minus A, and then the second derivative, x minus A squared, plus the third derivative, x minus A cubed, and so on and so on. That's a Taylor series. Well, then the other one is a Maclaurin series. And there's not much difference. A Maclaurin series is a Taylor series centered at 0. So basically this would just be f of 0 plus f prime 0 times x plus the second derivative evaluated as 0, 2 factorial times x squared plus the third derivative evaluated as 0, 3 factorial times x cubed, and so on. Oh, let's see. Then they talk about in terms of the binomial coefficients. And so p k is going to be given by p times p minus 1 times p minus 2 p minus k plus 1 all over k factorial. Right? And then p to the 0 is going to be 1. So we want to know what are the coefficients for something like this. Well, this would be x cubed, 5, 4, x to the fourth plus 5, 5, x to the fifth. And if you were to do this out, this would be 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the fourth plus x to the fifth. Right? So binomial coefficient. And then one last thing, just another example. Let's say I want to differentiate the Taylor series about, that's not very good. Try that again. About 0. And so let's say f of x is equal to e to the x. Right? And then it ends up the Taylor series expansion for e to the x is given by this. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, 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 dot. And there is a table in the book, table 9.5, which has Taylor series for a bunch of different functions. So if I were to take the derivative of this, so now I'm going to take my derivative. Well, this would be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, 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 plus x to the n over n factorial. And of course, this is still e to the x, right? And this thing would converge from negative infinity to infinity. Right? And that will conclude this video.